Now we'll talk about solving equations that have a degree higher than 2. Also radical equations, equations with rational exponents. We'll use substitution to solve equations, and then finally absolute value equations. So we're going to start off with polynomial equations, and those quadratic equations from our last section were also technically polynomial equations, but these will be higher order equations, so higher degree. So if you look at number 1, 4x cubed minus 12x squared minus 9x plus 27 equals 0. We've got 4 terms, and the highest power is 3, so we have a degree 3 polynomial. So it's not quadratic because it's degree 3, it's got a power of 3. So we've got to try something different. So in general with polynomial equations, I would say first try factoring. That's your first step, and then see what you're dealing with after that. So for number 1, we said that we have 4 terms. And in general, when we have a 4-term polynomial, we can factor that by grouping. So grouping is when we split them into 2 terms, so one pair and a second pair, and then we pull the GCF, the greatest common factor, out of each pair. So just looking at 4x cubed minus 12x squared, my GCF would be a 4x squared. That's the greatest common factor I can pull out. And then when I factor that out of 4x cubed, that leaves me with x. And then from the minus 12x squared, dividing that by 4x squared leaves me with minus 3. All right, now over here on the right, we've got negative 9x plus 27. And remember, if we try to, I'm going to write this above, if we try to pull out a positive 9, then technically that leaves me with negative x plus 3. And that's not that helpful because remember we want whatever's inside the parentheses to match between our 2 pairs, and it doesn't. So I pulled out a positive 9 and it didn't work so great. Let's try pulling out a negative 9. So remember, a good rule of thumb is whatever the sign is of that first term in your pair here, try to use that as the sign of your GCF. It won't always work, but often it does. So let's try factoring out a negative 9. If we factor that out from the first term, that leaves me with positive x, and then positive 27 divided by negative 9 leaves me with a negative 3, so minus 3. Okay, so at this point we're in good shape. Notice that we have x minus 3 repeated. So now x minus 3 acts as our greatest common factor, and I'm going to pull that forward. So I'm going to factor out that x minus 3 binomial factor. And I'll write what we have left, which is the 4x squared, and then the minus 9. And that's still set equal to 0. And then from there, I have 4x squared minus 9 in that blue second factor. That can be factored further, right? So 4x squared minus 9, I can factor that using a difference of 2 squares technique. So I can factor that as 2x plus 3 times 2x minus 3. And then that original x minus 3, we'll just pull that down. And now we're going to set each factor equal to 0 to get 3 potential solutions here. So our first factor, x minus 3 equals 0. We solve that and get x equals 3. We can set 2x plus 3 equal to 0. Subtract 3 and then divide by 2, and that will give me x equals negative 3 halves as a second solution. Or we can set 2x minus 3 equal to 0, add 3 to both sides and divide by 2, so this gives me x equals positive 3 halves. So x equals 3 or negative 3 halves or positive 3 halves. So in this case we factored, then we factored a second time, so make sure you fully factor. And then we were able to set each of these individual factors equal to 0 and solve. When we get to number 2, we've got x to the 4th minus 5x squared plus 4 equals 0. So this is also not quadratic, but notice it's kind of got that same pattern as a trinomial that we would have factored back in the last section. So for example, if I had, instead of x to the 4th, if I had x squared minus 5x plus 4 equals 0, I would factor that as x minus 1 times x minus 4 equals 0. And then I would set each factor equal to 0 to get x equals 1 and x equals 1 or x equals 4. Looking at number 2, though, we have a higher degree polynomial, but we can still factor it in the same way. So what if we factor this as x squared minus 1 times x squared minus 4? And let's pause just real fast to make sure that we factored that properly. So let's go ahead and FOIL this just to check it. So if I FOIL this, I'd have x squared times x squared, which would be x to the 4th. Then I'd have minus 4 x squared minus 1 x squared, and then negative 1 times negative 4 would be positive 4. So I see that I've got my x to the 4th. I see that I've got my plus 4. And then the minus 4x squared minus 1x squared would add up to the minus 5x squared. So I factored correctly. Okay, so looking at these two factors, now I've got x squared minus 1 times x squared minus 4. Both of these can be factored further using a difference of two squares factoring technique. So I'll split x squared minus 1 apart into x plus 1 times x minus 1. And then I'll split x squared minus 4 into x plus 2 times x minus 2. So this gives me, this gives me 4 solutions. So from my first factor, x plus 1, if I set that equal to 0, that would give me x equals negative 1. From my second factor, x minus 1 equals 0 would give me x equals positive 1. From my third factor, if x plus 2 equals 0, then x would equal negative 2. And then setting x minus 2 equal to 0 would give me x equals positive 2. So I end up with 4 different solutions. All right, so in this case, again, I factored and then I fully factored a second time. I just want to point out that you also could use your square root property. So we got to the point where we had x squared minus 1 times x squared minus 4 equals 0. We could have set each of these equal to 0. For example, x squared minus 1 equals 0. Set that factor equal to 0 and solve. To solve this, probably the fastest way would be to add 1 to both sides. This gives me x squared equals positive 1. And then from there we could use our square root property, make sure we include that plus or minus. And this gives me x equals positive or negative 1 as one solution. And then if we did the same for our second factor, x squared minus 4 equals 0, x squared equals 4. Using the square root property, we would end up with x equals positive or negative 2. So we still end up with our 4 solutions, whether we fully factor or whether we use the square root property. Okay, so that brings us to number 3. So number 3, they give us a hint in the instructions. They say solve by factoring and using the square root method. So similar to what we just did. All right, so we've got x to the 4th minus 3x squared minus 10 equals 0. And again, this is not quadratic, right? We've got x to the 4th power, so it's not quadratic. But it looks like those trinomials that we're used to factoring. So for example, if we had x squared minus 3x minus 10, if we had the same coefficients, but that usual x squared x and then constant pattern, I would factor this as x minus 5 times x plus 2, right? So over here, if I want to factor the actual polynomial that I'm given, what if I factor it as x squared minus 5 times x squared plus 2 equals 0? And you can go ahead and FOIL that back out just to check, and you will get back that original x to the 4th minus 3x squared minus 10 if you FOIL that out to check. So from here, I've got x squared minus 5 times x squared plus 2 equals 0. In example number 2, when we got to that point, we went ahead and factored, but we had like x squared minus 1. That's a difference of 2 squares. In number 3, we don't have a difference of 2 squares in either of our factors, so the logical next move is to go ahead and set these equal to 0 and see what we can do with them. So x squared minus 5 equals 0, or x squared plus 2 equals 0. And because we can't factor these further down, we can go ahead and use that square root property like we did before. So if I add 5 to both sides, that gives me x squared equals 5. Then taking the square root of both sides, remembering your plus or minus, that gives you x equals positive or negative square root of 5. So there are two possible solutions. And then for x squared plus 2 equals 0, subtract 2 from both sides. This gives me x squared equals negative 2. Take the square root of both sides. Using the square root property, include that plus or minus. So x equals positive or negative square root of negative 2. And remember that we have to pull out our I. We have to get rid of that negative sign underneath the square root. So we eventually end up with x equals positive or negative plus or minus I times the square root of 2. So we have two real solutions and two imaginary solutions.